Welcome to another 3 steps to sketch. This time we are going to be looking at our method for graphing more advanced cosine graphs. So these are cosine graphs that have been shifted, and they're in this form: y equals a cosine of bx minus c plus d. Okay, so this is going to be a modification of the method that we have been using for graphing more basic or unshifted cosine graphs. It really does build on that, so go check out that video. There is a link in the description if you want to really get that method under your belt before moving on to this more advanced method. Okay, so here is the method outlined, and then we'll dig into each step on its own. Okay, in our first step, we'll find the essentials. That's very familiar. We are always going to do that first for our trig graphs. Okay, step 2, we'll plot our base pattern, which will also feel very similar to the basic method. And step 3, we've modified just a little bit. We'll shift, sketch, and repeat. Okay, so before we dig into our steps, here's a quick tip that really makes this method flow so smoothly, and it eliminates the possibility of a few errors that are pretty common. So you want to rewrite your equation to factor out b if it isn't already factored out. Okay, so here's the non-factored out version. And this will look a little general, so watch some of the videos where we use this method in examples, and I think it'll make this feel a lot more clear. But we will look at one example quickly here. Okay, so you're going to rewrite it factoring out b. And you can always double check yourself distributing the b back through by multiplication. But this looks probably a little funny. Again, check out some of the examples. Why would we do this? And it's so that we can clearly see the phase shift. Okay, the phase shift is c divided by b. Okay, a very common mistake is people assume that c by itself is the phase shift when that's not the case at all. And by taking just this quick extra second to factor out b, you will eliminate the possibility of that error. So let's see quickly what that looks like. So here we have an equation. You can tell it's a shifted cosine, so we need the more advanced method. We have y equals cosine of 2x minus pi over 2. Okay. So b is clearly right here. It's this 2. And we want to factor it out. So we'll have y equals cosine of 2 times x minus pi over 4. Okay, a quick way to factor that out is just to take c, which is this, and divide by b, which is 2, and you'll know what it's supposed to be. But again, you can double check yourself by just distributing that 2 back through. And you'll make sure that you match what was the original. Okay, so this is how you would factor out b. We'll see lots of examples where this is necessary, but for now we'll leave it here and we'll dig into our steps for our advanced cosine graph method. Okay, so step 1 in our advanced method is the same as the basic method. We're going to find the essentials. And you'll see that we are going to add a few pieces here, but for the most part, our information that we're finding should feel very familiar because we do find it with our unshifted cosine graphs as well. Okay, here is our equation with b factored out. And we'll start by analyzing a, b, c, and d. Our horizontal transformations, they happen in the input of the function, are b and c. So b, as we know, tells us how many cycles we have between 0 and 2 pi, and we also use it to find the period of our graph, or the length of a horizontal cycle. And we do that calculating 2 pi divided by b. Okay, we also can find our phase shift. We do that by calculating c divided by b. And phase shift is how, in the trig world, we describe a horizontal shift. We just call it a phase shift. Okay, and so here's the benefit of our factored out equation, where b is factored out. You can see the phase shift staring at you right here. Okay, and similar to other horizontal shifts, if C over B is positive, we'll move right. If it's negative, we'll move left. Okay, so you'll see x minus, let's say, 2, you'd move to right. If you saw x plus 2, that's actually hiding that the 2 is negative. We move left 2. Okay, so those were our horizontal transformations. Now our vertical transformations happen around the cosine function. Those are A and D. So A, just like we've seen before, can tell us the amplitude. We just take the absolute value of A because amplitude's a distance. It's a measurement of midline to maximum or midline to minimum. And then D is your vertical shift. So if you see D is positive, you move up. D is negative, you move down. That should feel very familiar to all of the other transformations you've done for other functions. Okay, and what you'll see is what you're going to do, because if you see a +1, you'll move up 1, a -1, you'll move down 1. All right, so then the final part to wrap up the essentials is to choose scale labels. And if you are familiar with the 3 steps to sketch method for cosine and other trig graphs, you know we do this very intentionally, especially for our horizontal labels. We want to make sure our graph is really nice, neat, and our key points in our pattern, which we'll get into in the next step, we want to make sure those align nicely with how we've labeled our tick marks. So we will take our period and divide by 4, and we'll use that value for our horizontal labels on our horizontal axis. Okay, so period divided by 4. That's really important. Our vertical axis, we can label by taking the absolute value of A, or a lot of times 1 will work. So step 1 is a lot. It's a lot of analysis, a lot of breaking down the pieces, making sure you know what you're working with. It's the meat of the method. But once you've done it, the other 2 steps really should fall into place. They should be pretty fun, actually. So before we move into those, I want to take a quick second to point out the 2 pieces that are new. They are part of the advanced method. They're our modification of the basic method. And those are our shifts. So the phase shift, C over B, and the vertical shift, D. So once you've learned that basic method, you really aren't having to add on that much. You're just making a small adjustment to account for these 2 new pieces, and it should be a really quick thing to master. Okay, so now we move into step 2, where we'll plot our base pattern. Now, in the basic method, we said step 2 was to plot the key points, so we still are plotting key points. We're calling it the base pattern. When you plot this base pattern, we are not taking the shifts into account yet. That we're saving for step 3. So you want to plot this graph lightly, this pattern lightly, because we'll be adjusting it with shifts in the next step. All right, so we will still be working from our factored out equation and our base pattern. So for cosine, that's going to be maximum, 0, minimum, 0. 0 is just another name for x-intercept. Okay, so you can find that. Our maximum will start, again, this is before we shift. This is for our base. We'll start on the y-axis. So we'll find our first point using 0a. Our first 0 or x-intercept will happen at our first horizontal tick mark to the right of the origin. Our minimum will happen at the second horizontal tick mark, and its y-coordinate will have an opposite value of a. And then the final 0 in the pattern will be at the third horizontal tick mark. Now, this is working when when a is greater than 0. You just have a small adjustment if you do have a negative out front. If your a is negative, your base pattern, you can still follow this guide, this template, and you'll end up with the right points. But instead of the pattern as it is, you'll actually label it minimum 0, maximum 0. Because when a is negative, you have a vertical reflection or a flip over the x-axis. So that's just something important to note. And there's a quick reminder of what I just said. So it just basically swaps the minimum and the maximum in terms of what you would label them. That'll be pretty obvious when you see the graph. Okay, one other thing to note. So in this step, like I mentioned at the beginning of this slide, we're graphing the base function or the base pattern. So essentially you're graphing y equals a cosine bx. We're just totally pulling out the shifts. We've already analyzed them in step 1, and we're staving them for the next step, step 3. Okay, so we're going to tackle those. Make sure in step 2, when you plot your base pattern, you're doing it lightly because we are about to move that. All right, so step 3 is just a modification of the base method. In this step, you will shift, sketch, and repeat. There's the reminder of the equation. So from the base pattern in step 2, you'll apply your shifts. So you'll move right or left for your phase shift, up or down for your vertical shift. Okay, so we have our phase shift, which, reminder, it's just C over B, and our vertical shift will be D. Okay. Once you have shifted it, you'll sketch the graph through those final points, those shifted points, and then you'll be able to repeat that pattern, that final pattern, for as many cycles as you need. Okay, so now let's take a look at a template that you can use when tackling examples that will follow this method. Okay, so on the left you have the method and you have the template. You have the reminder of the steps, and notice that in step 1, that's where you're finding the majority of your information, and you'll have your information broken down into your base graph and your scale labels, which you'll use in step 2, and this will be everything that you would have done in a basic or unshifted cosine graph. And then we'll work on the shifts, which you know will be used in step 3. Okay, so it's purposely organized like that, and I think that really makes sure that you consecutively work and have all your pieces in place for when you need them. So without working a full example, check out the links in the video description. There will be plenty of examples for all kinds of graphs there. But let's just see what something like this would look like. So let's say we had just a very basic cosine graph, y-intercept, which is a maximum, a 0, a minimum, a 0. Okay, and then you would restart the next cycle. So this would be step 2. Say you found all that information. Doesn't matter exactly where we are. We just want to see what this looks like. Okay, so this is plotting the base pattern. We'll call this step 2. Okay, and then in step 3, we'll take each of these green intermediate points from step 2 and apply whatever shifts. So let's say we had shifts that were equivalent to 1 unit horizontally and 2 units vertically. So take each of your green points and you'll move right 1 unit and up 2 units. And then you'll plot what will be your first final point. So you do that with each of your points. Okay, again, this is just a general example so you get the idea of how this will happen. Watch some of those videos of specific examples and this will all really, really fall into place. Okay, but for all of these, we move right and up, and then you would sketch your graph into place. Okay, you could repeat if you wanted to. So you would just move 4 units or 4 horizontal tick marks to the left, 1, 2, 3, 4, and you would repeat the purple pattern, and you would see you have another cycle of cosine. All right, so this is the 3 steps to sketch method for graphing the more advanced cosine graphs. You might see these are your shifted cosine graphs. So a reminder, in the video description, there are links to lots of examples, and even if you're interested, links for examples that are other trig functions besides cosine. So best of luck and keep up your practicing.